The Dragonfly drone platform is actually stored in a modular fashion inside of a Pelican case, which you'll see right here in the video. It takes about 90 seconds to set up from opening the case to being ready for the first flight. And the setup is made up of three major components. One is setting up the propellers. Two is actually putting on these prop guards, which come with a very easy locking mechanism so they can be hot swapped in case of any issues or in case of in between flight maintenance. And three is actually putting in a battery, which can be done within about 20 seconds. For the first flight of the day, we also take measurements just to make sure the drone is lined up correctly inside of the hangar, just to help the drone get localized for its first flight. Before we actually do any inspections with the Dragonfly platform, we create a digital twin of the hangar using our LiDAR data and our point cloud data in order to build a known map and coordinate system of the entire operational hangar. This is something that's used to allow the Dragonfly platform to navigate freely through the environment, as well as help it localize and modify its settings as it flies through and around an aircraft. And here in the video, you can actually see that map slowly being built. As the drone platform, which is that big blue arrow, flies around the plane, we see that the environment is slowly being populated with more and more data. You can see on the bottom left-hand corner, there's some ladders and equipment that's found in the hangar, as well as a few personnel who were watching the demo. The colors actually differentiate the different altitudes that the points are seen at. This is incredibly important for our obstacle avoidance and sense and avoid systems. When building these maps, the drone is able to see all little obstacles hanging from the ceilings, like harnesses, as well as static and dynamic objects like ladders, stairwells, and pillars. Here is actually a 3D model of the hangar that's built after one of these flights is completed. And this is extremely important because now the drone knows where all objects are in the hangar and it knows how to avoid any both seen and unforeseen objects while it's flying around the plane. This is to mitigate any possibilities of interruption during these inspections. You'll notice during some of these flights that there is a flight engineer keeping an eye on the Dragon platform. This is due to the fact that we need to keep an eye on the drone and verify that it is operating at 100% capacity. The Dragonfly platform is also equipped with a state-of-the-art industrial camera as well as a 360-point LiDAR system, which allows it to detect millimeter accuracy levels of data around the plane, as well as navigate freely in these dynamic and different environments. A gimbal system is also attached to the camera, which allows for multiple views and stability in our video. The drone flight time is 20 minutes, which usually means one or two battery swaps need to be done in order to accomplish an inspection, depending on the plane. We've built a novel system which allows for a 30-second battery swap. The battery is actually connected to the drone using two power wires as well as Velcro adhesives, which both secures the battery but also makes it extremely easy to pull out or insert back into the drone. Right there was a full battery swap sequence that took less than 30 seconds. Here is some video of the drone actually flying in the American hangar along one of the A321 planes. At the top, you can see the drone slowly flying along the right-hand side of the plane, and on the bottom, you can actually see the first-person view of the video and pictures that the drone is capturing. As we're using an industrial-grade camera, the drone doesn't actually record video. Instead, it takes a series of snapshot pictures, which are then combined together to perform a video. This is important because each of the pictures taken is about 12 megapixels of resolution, which is incredibly detailed. This allows us to break those pictures down into subsections and run detailed analytics on what we're seeing.
Once logged in, you'll be taken to our main dashboard. From here, you'll be able to view previous inspection history tasks, create a new inspection task card, and contact support. Let's go ahead and begin the new inspection. You'll start by entering the name of the inspection location of the facility, tail number of the aircraft, and aircraft type. We're developing APIs that will pull this information from your eMRO platforms, so a manual process will no longer be required. You'll then go ahead and select a drone and initiate an inspection. Once the drone begins its inspection, you'll be able to view the drone's first-person camera and follow along. When an aircraft inspection is completed, a news task card will populate. Tap on View and you'll be taken to the report of the inspection. You'll see two screens. On the right, a digital twin of the aircraft that was inspected, including all potential damage areas of the airframe. And on the left, you'll see a screen that shows a list form of the damage areas that you'll be able to interact with. Let's take a look at the left wing. Go ahead and click on See Detail. We can see Dragonfly has identified several issues including holes, cracks, scrapes, and paint tears. Let's review a paint tear on the top control surface. The Rizse-AA has identified the wing and provided a confidence metric of the damage. The technician has the ability to highlight additional damage areas and reclassify misidentified damages. Measurements are done using photogrammetry to provide length and width of a damage. Rise is currently developing a feature to identify the depth of the dents and have implemented that development in our product roadmap. Tolerances are pulled from maintenance manuals such as SMMs, AMM, SRMs, and GLMs. Integration of these manuals require partnership with airlines and are currently pending integration. Technicians can flag an issue for further review by another technician, even if that technician is remote. Once complete, you'll tap Mark as done. Now rinse and repeat. When an inspection is completed, a PDF report can be generated. This report stands in place of EMRO integration, as we're currently developing out that procedure. Since DCC has yet to be fully completed, we have the ability to work with American's IT and Tech Ops to custom tailor the application to meet your needs. Thank you again, and have a wonderful day.